Hey physics, I wanted to do a video about this assignment because I noticed that a lot of people struggled with it and it took me a while to get to it to grade it. Um, and I wanted to give like really detailed feedback for you, but I noticed that in some classes there's a bunch of you that have not done it yet. So I wanted to make sure that I take a minute to go through this assignment in particular so that if you haven't done it yet, if you're feeling lost on it, you have like a guide to help you through it. Okay, so let's get right to it. I'm going to go pretty quick through it. This is the answer key that is already posted for you in the Google Classroom. But I'm going to kind of go a little bit more into why we chose the answers that we did, okay? So when we're looking at independent versus dependent variables, it's important to know that variable on its own means something that changes. You know the word vary, meaning like it varies, you know, like it changes from thing to thing. So the independent variable is the thing that scientists decide what it is. They decide how it's going to set the pace for the experiment, okay? So it doesn't really matter what the results are. That independent variable is going to go forward at that regular pace. So here in this one, the independent variable is the time heated, and you can tell because the numbers go up at this really regular rate. So this looks like something the scientists would have decided to make like that, 5-minute increments. And then the dependent variable is what we're really looking at here. It's like the whole point of the experiment. We want to know, you know, if we heat this oil for a certain amount of time, which is this amount of time, then what is the temperature of it going to be? So this is the dependent variable because it depends on when we're looking at, okay? And then this one, it's really fine either way. Okay, so height range. So this one, the independent variable is height range because this is the thing that scientists are deciding, like this is how we're going to break up the chunks of heights. We're not looking at like, you know, just a spectrum or anything. We're looking at like under 4 feet, you know, it's like every 6 inches is like a chunk of height that you could be. And then the dependent variable is how many students are that height. So I saw some people do other, you know, they kind of came up with experiments where they talked about how many girls have a certain shoe size, anything like that. The thing you're judging on is going to be the independent variable, and the number of people that are in that category is the dependent variable, okay? So this one, the independent variable, is the salmon species, because that's the thing, like that's the thing that the scientists are deciding, this is what we're going to look at, or like how we're going to categorize the things we're looking at, and this is what our results are, the different heights, okay? This one was kind of cool and tricky because usually, as you notice, the independent variable is on the left side and the dependent is on the right. But in this one, it actually looks to me like the atmospheric pressure is going to be the independent variable because I see it going up at these kind of regular amounts. It's not like the same amount each time, but it's like 1 atmosphere, 0.75 atmospheres, half of an atmosphere, a third of an atmosphere, a tenth, a hundredth, and a thousandth of an atmosphere. So that is the independent variable there. But if you put something different, I didn't mark you wrong on that one because this one's kind of hard to see. And then the meters is the dependent variable because it depends. The atmospheric pressure depends on what altitude you're at. Okay? Or the altitude depends on, yeah, the altitude depends on what atmospheric pressure you're looking for in this case, okay? So I want to give you some tricks for making your graphs work well and getting your full points on your graphs. The first one is really important, and it's to copy and paste your data set over if you need to. On the test, when you do that, then you're going to have all that information there for you, but on some of these assignments that you had to work on your own, there was a little bit less of that scaffolding. You might have had to move this in order to be able to see it. Okay, so that's my first advice. Second advice is make your title. And when you make your title, sorry, my dog's right here. He's like, why are you talking so much? When you make your title, it needs to say what's going on in the x-axis and the y-axis, okay? So this is like a really clear species of Pacific salmon versus the weight of the salmon, okay? So I can see that we're looking at what does each species of salmon weigh on average, okay? And it's really important you have your units there. So here the units are pounds. Here it's just species of salmon, but I made sure to say that that's what those words are. And the other thing you want to do is to space out your numbers so that you're taking up the whole graph, okay? That just is really important for making it look nice and easy to read. Okay, claim evidence reasoning. This is really important. This is a big part of everything we're learning in this unit, and we're going to keep coming back to it because I think it's a really important thing to know how to do good science writing in this way. A claim in evidence and reasoning is looking at your graph and saying something about it, okay? And backing that up with what you can see in the graph. So the claim for this one here is going to be, my dog's like, what are you doing? The claim is going to be, you're going to say something about that graph. So this graph, I might say that king and chum salmon are both are the two largest or heaviest species, okay? And the evidence is going to be some numbers from your graph to back that up. So they both weighed an average of 15 pounds. Okay, that's my evidence. It's a number from the graph that's backing up what I'm saying. You could even connect that to expand and say, like, they both weighed an average of 15 pounds, whereas, that's a good comparison word, whereas the other species of salmon ranged from 5 to 12 pounds, okay? That'd be good evidence there. And then the reasoning is going to connect your claim and evidence to some broader scientific knowledge. So for example, and with these, like, I'm not going to be like, your scientific knowledge is wrong, because we're mostly just like looking at, do you know kind of like what you should be doing here. So for this one, you could start with like perhaps king and chum salmon have the most secure habitat and least predation. Or I think on some of the comments I put, perhaps king and chum salmon spend more time in the food-rich ocean before returning to their home rivers to spawn, or something like that. You don't have to know specific stuff like that, but just connect it to some kind of broader knowledge about that topic, okay? All right, so then we have this oil heated and final temperature, and again, you can tell right from the title what this graph is about. Don't be cryptic. Like, science writing is super straightforward and direct, puts words in boxes that are already there, so don't fight it, just like make it really clear. Ooh, and I see something that I should have done here. I needed to capitalize the important words in my title. Okay. And again, you can see time heated is my x-axis and final temp is my y-axis. So I copied and pasted my data over here. I filled up my space. I've got my units here. It's degrees Celsius and minutes. I could have probably expanded this a little bit farther this way, but that's kind of what I'm looking for there. And again, claim, I'm going to say something specific about the graph. The final temperature of the oil has a direct relationship to the amount of time heated. You always kind of get bonus points for using those good vocabulary words, direct inverse, no relationship, or strong relationship, weak relationship, or no relationship. Oh, and I should have said complex or nonlinear relationship is the other one that you could do instead of direct or inverse. Okay, so evidence is going to be oh my gosh, like I have improved at this since grading all of your stuff. The evidence is going to be best to use some specific numbers from the graph. So for example, at 0 minutes, the temperature of the oil was 21 degrees, whereas at 20 minutes, the temperature was 57 degrees. Yeah. So that's a good thing. And again, this is a good place to talk about a direct relationship, inverse, complex, nonlinear, something like that. And then the reasoning is going to connect it back to some broader scientific knowledge. So for this one, I was like, well, maybe perhaps since oil is such a thick substance, a viscous substance, that could cause the heat to accumulate at a very steady, regular rate. Okay? So that's what you're supposed to do there. I'm going to end this video here. So you're going to want to go back through this assignment, fill it in. If you haven't, you can use the things that I've put here for you. You've got the answer keys for everything. Go through your other assignments, make sure that they're all good. I think I'm only going to grade you on this one, but the other two are good for you to test yourself and make sure that you know all the things you need to know for this, okay? So I will see you guys soon. Bye.